Here's a quick overview of what we did in class today and what your first day 2 to the semester will be. Just a review, log into Canvas, click on this Max Patches link. You have all the files that we were working with in class. These are 2 folders, one full of short piano harmonic samples, the other one full of mostly longer samples of door sounds. It's very musique concrète. These are the 3 patches we were working on, 2, 3, and 4. Download all this stuff, create a new folder wherever you want, name it whatever you want, obviously. And then all the things you just downloaded, drop them into that new folder. Okay. These zip files have to be uncompressed. Usually double-clicking does the trick. You can delete the zip files after that. Again, these are just samples of doors. These are shorter samples of piano harmonics. There's about 50 of them, 70 of them, I guess. Once you have that downloaded and ready to go, open patch number 2, playlist control. You might get an error message here where, I don't know what this means. You can delete that. This is how you clear messages, clear your Max console. You might get a bunch of error messages here that they can't find your playlist audio files. If that's the case, go up to Options, File Preferences, add a path right here. Click on Choose to select what path. Wherever it is you saved that folder, wherever it is, the folder in which you saved all the files that you downloaded from Canvas, all you need to do is select that and hit Open. Okay, make sure Subfolders is clicked. By selecting subfolders, you're essentially telling Max that this user path into this folder, January 17th, and all the folders inside of that folder will be now included into Max's search path. I actually didn't get an error message, so I'll just remove this. You shouldn't remove it, just leave it there. And then all you need to do is close Max, reopen that same patch. Hopefully you will not get error messages. If the error messages persist, if you keep getting them for whatever reason, you can just drop the audio files in manually. Okay, just select whatever audio samples you want, unlock your patch with Command E, drag and drop these into Max MSP. You should get a playlist object with a bunch of these audio files. You can resize it, do whatever you want. And then all you have to do is copy that, Command C or Control C in Windows. Right click on this and type paste replaced. And what it'll do is it will take all the audio files, the playlist object with a bunch of audio files that you just dropped into Max, and it will replace the current existing playlist object. You only need to do this, again, if you're getting error messages loading the audio files. Again, I will just go back to how things were normally, and then we'll move on. So just remember that you have to turn the volume up and turn DSP on. This needs to be illuminated. You can turn DSP on down here as well. In order to get sound, right? You can play these files manually by clicking, or you can scroll through them. What I'm doing is selecting this. My patch is locked. I select this integer box, and then I press arrow up. You can see my keystrokes down here on the bottom left of the screen. Right? That's a nice way to just play linearly through all the playlist objects, all the playlist files. Now, what we want to do is control this in different ways. We can play through the sampler linearly with a metro and a counter. This is just a very basic sequencer. We turn metro on, and every 500 milliseconds it sends a bang right here. Right? This is just to see the bang. A bang is just a little packet of essentially a 1, and it tells the next object in line, do whatever it is you need to do. Okay, bangs are very common in Max. We don't hear anything because the volume is down. But this is a good way to just play through, cycle through the files in the playlist object. We can change this argument by attaching an integer to the right inlet of the metro object. Right now it's defaulting at 500. That is the initial argument of metro, but we can change that to whatever we want to. This will be in milliseconds. So higher number is actually going to be slower. Now it's sending a bang every second. Now it's sending a bang every 250 milliseconds. Right? You can of course click and drag this to gradually speed up and slow down. Very versatile object. I recommend you take some time and explore it a little bit. What's going on here is every time Metro sends a bang, it counts from 1 to 5. Right? When counter receives a bang, it counts through this number, this range of numbers. Remember, hovering over this second inlet, you can set the direction. If this is a 0, it will count up. If it's a 1, it'll count down. If it's a 2, it'll count up and down. So we can attach an integer to this. Here it's counting up. Here it's counting down. And here it goes up and then down. Any other number will not affect the counter object. And it doesn't matter if this is actually an integer or a message. You can have a message object that has a 1 and a message object that has a 2 attached to the same inlet. I'm clicking on the 1. Oh, it doesn't work. Interesting. So it does have to be an integer. Oh, that's good to know. Oh, I think I wasn't setting it as 0. In any case, it doesn't matter. This lets you change the direction of the counter. Okay. Here's a little area of this patch that lets us randomize the samples. We can see that random is producing, every time it receives a bang, it generates a random number between 0 and 4, one less than this argument. It's essentially generating 5 random numbers starting at 0. In order, as you can see, when this is a 0, the playlist doesn't play anything. In order to avoid this problem, all we need to do is add 1 to the number generated by random. And if we were to then attach an integer down here just to see what's going on, you can see now it's actually generating numbers between 1 and 5. But as you see there, occasionally you'll get a bunch of random, a bunch of repeated numbers, which might not be really desirable. In that case, what we want to use is earn. Earn is just like random, but it does not duplicate numbers. Basically, it goes through all of the numbers between 0 and 4 once, and then it stops. So if we were to hit play right here, turn the Metro on, it would send 5 bangs. It would send a bunch of bangs, but after the 5th bang, this would stop sending numbers. You see? Because then, after it's depleted all its numbers, it stops working. So what we need to do, I think, is send it a message. What message do we have to send it? Clear. That's what we need to do. You send it a message that says clear. And it will reset, basically. Earn has a really interesting little process that is really common, little like a trick that's really common when we're using it. The right outlet here will send a bang when all the numbers in the range have been chosen. Basically, when the numbers have been depleted, it'll send a bang. We can attach this to the left inlet of the message, and when this message thing receives a bang right here, all it's going to do is send this clear message. That clear message will then be sent to the left inlet of earn, and it will clear. It'll essentially reset it. So what that does is it cycles through all the random numbers. When it's depleted them, it clears it and it starts over again. So that ensures basically that the probability of having 2 repeated numbers is really, really low. It would only happen if it ends on one number, and then randomly the beginning of the next cycle is that same number. We have the same problem that we had with random object, in that it's creating random numbers between 0 and its argument. So we're going to add a 1 as well to avoid that issue. So right here, if we interesting. So there's that one bang that it receives in order to clear this message that is sort of a rest in the sequencer. I'll have to think about that and think what we can do to resolve it. But in any case, this is the patch 002. take some time, get to know it, play around with it, explore the possibilities. We didn't really look at this one in class, so I'm just going to jump ahead and look at patch 004. Play this with keyboard and mouse. This is what your etude for next week will be based off of. In this case, we were looking at the key object and the mouse state object. The key outputs the corresponding ASCII number of each key on your keyboard. So if I were to type the letter E, lowercase e down here corresponds to the number of 101, right? Uppercase E corresponds to the number 69. Every key on the keyboard has a different number. Using the select object, what we're able to do is then send the key object, which reports the number corresponding to the key that you press on your keyboard. It will send that number into select, and whatever argument we give select, if the input matches that argument, it will send a bang. Okay, so the number 81 corresponds to capital Q. If I were to press the capital Q, uppercase Q, this sends out an 81, as you can see up here. It matches the argument in select, and so this sends out a bang and turns on the toggle object. You can press T to create a toggle. It's a really useful object of basically flipping a switch up and on and off. If we then hit capital Q again, it turns it off, right? Q, in this case I've programmed Q, W, E, and R. All capitals. The reason that we're using caps is so that things don't get triggered while I'm programming and I'm typing. You generally will program in lowercase and max. You know, you can type all your good stuff, your comments and program object names and all that. And what you don't want is for this key object to be randomly triggering stuff while you're doing that. And so to separate essentially your programming mode and your performance mode, I often like to reserve the triggers that I'm going to be using in my patch for things when, just for caps, okay, when things are uppercase. That way when I'm programming, it doesn't interfere with the patch itself. Ignore this for now. That's from a leftover from another patch. So with this, we're now able to, if I have caps on, Q, W, E, R. Unfortunately, right here doesn't indicate whether it's uppercase or lowercase, but I can turn these things on and off really easily. So all I need to do is duplicate this. We know that these correspond to Q, W, E, and R. Oh. Whoa, I don't know what happened there. Interesting. Maybe caps was on. So Q, W, E, R. These are going to be essentially the triggers. This is just so that I know what's what here. So I'm going to attach Q to the play object. When I hit capital Q, it's going to play back. When I hit capital W, I want it to turn looping on. Capital E turns time stretch on. Actually, let's replace these comments, and I'll just put caps is on again. There we go. So Q, W, and E, just to see what's going on. Okay, so caps on, turn looping on, and I can turn time stretch on and off with E. Now, the more interesting thing that we were doing in class was with the mouse state object. When you click on poll, mouse state actually tells you where your horizontal position of your mouse is, 0 to whatever the maximum number of pixels on your screen. It also reports the vertical position, 0 to the maximum number of pixels on your screen. The horizontal and vertical delta is the direction in which you're moving and how fast you're moving in that direction. We were missing, again with the caps, we were missing a button. Actually, I'll put a toggle here, which indicates when you push the mouse button, right? If I click on the mouse, it sends a bang. It's a little bit hard to see these numbers, so I'm just going to make these a little bit bigger so that we can see the minimum and maximum area of the screen. So top left corner is 0, 0. I've got little shortcuts in the corner, so it triggers that weird thing. But this is 0, 0, and then the maximum is 1918, 1920 to 1080. Okay, so what we want to do, what we began working on in class, is having your vertical position control the speed of playback, and having the horizontal position will control the speed of playback, vertical position will control the pitch shift. So we're going to use the scale object one of the most important objects we'll be using this semester. And it maps values, incoming values, to an output range. The arguments of scale are minimum input, maximum input, minimum output, and maximum output. So in this case, the 0 will be a 0, and when you send it a 100, it will output 1,000. Okay, and it will continue to go beyond that. It's a very, very useful object. I'll just move this down for now. Most of this should be review. If you do have any questions on the scale object, I recommend you look at the help file. It's really useful. It explains things in extreme detail. But what we're going to do is basically scale the horizontal position from 0 to 1920. We know our input is 0, 1920. Notice how this is not returning floats, it's returning integers. So these two arguments can be integers, but we want the horizontal position to control the speed of our playback, which is a float. So we want these next two arguments to be floats, -2 and 2. So we're going to have the horizontal location of our mouse go into the scale object. If you create a float, you'll be able to see what the corresponding value is. So when I'm all the way on the left, it's a -2. When the mouse is all the way on the right, it's a 2. Right? So this will be twice, playing backwards at twice the speed, playing forward at twice the speed. When the mouse is right in the middle, it won't play back at all. So now attaching this to the speed object, we can turn pretty cool. And remember that we can turn time stretch on or off. Okay. For the pitch shift, let's use the vertical position. So you see your vertical range is from 0 to 1080. So you're going to create a scale object, 0, 1080, and then whatever range you want your pitch shifting to be. Let's say we want it to be from 0.2 to 3 or 6, something ridiculous. Doesn't really matter. Remember the two right arguments, you want them to be floats. So if we hit play, turn looping on, time stretch on, you can play back fast and low, fast and high. And you can have a lot of fun with this. Now, the key, the sort of subtlety in this is going to be determining what these ranges are. So if you have like a -0.3 to 2, then our playback speed, as you see, right here will be at about 0. This will be at about -0.3. And then you have a lot more room to mess around with between 0 and 2. It'll be this whole area on your screen. So depending on how you scale the output of this, you're going to get very different results. Depending on how you scale the output of this, you'll get different results with the pitch shift and how you interact with the screen. This is really what I want you to explore for your first etude. So take any audio file you like. I would encourage you to explore, record your own files, download stuff. freesound.org is pretty good. It's usually mostly open source sound that you can download and use however you like. But you can just replace this audio file with whatever you want. So we can, let's say you find another sound that you really enjoy. All you got to do is unlock your patch, download that sound, put it in this folder, drag it and drop it. Make sure when you're hovering over the playlist that it's selected, the entire thing is selected in red. If you do that, it'll replace the current file. If you kind of hover it towards the bottom, and the bottom of the object is in red, it'll simply add an audio file to the playlist object. So for our purposes right now, you just really want one audio file. So make sure the whole thing is red. You drop it in there, unclick, let go of the mouse, and then you'll have a separate audio file, a new audio file that you can manipulate. Turn time stretch on. And of course, you can select just a little fragment of this if you like. We'll turn looping on. So the reason looping was off right there is because we replaced the audio file, and we didn't click this after we replaced it. So this new file didn't know that it should have been looping. It also didn't know that it was whether time stretch was on or off. So whenever you replace the audio file, make sure that you just re-click or kind of re-trigger whatever you need to up here. Any case, once you find a good audio file, test out a few different things, test out a few different ranges, then just actually practice. Practice high pitch, low pitch, fast and slow. Try to do interesting little solos or like timbral explorations. Just have a really good time with it. And then whenever you find a patch, an audio file in a system that works for you, what I'd like for you to do is save this file as your name. Save as 004 playlist with keyboard and mouse. Put your name in there, doesn't matter where. Save it. And then I would like for you to upload that file along with the audio file. If you're using a different audio file, I'd like for you to upload both of those things into Canvas. Okay, and then we're going to have an in-class performance on Wednesday. But come prepared. You should really know your instrument. You shouldn't have any technical difficulties. You should be able to play really low, really high pitch. You should really know things inside and out. Okay. If you have any questions, please email me, and I'm going to post a few other additional tutorials and things on Canvas. All right, enjoy.